Okay, so for this example, we want to find the discontinuities, if there are any, for this piecewise defined function. And the first thing you'll notice here is that the pieces of the function are both linear functions, and therefore they're polynomials, and therefore continuous. So the only places we have to be very careful about are the places where we piece our function together, which is namely x equals 1. So to do this, we're going to need to find the limit. And so to find this limit, we're going to have to take a look at the left and the right limits for this function. So let's first focus on the left limit. That's the limit as x approaches 1 from the left of our function. And you'll notice that we have to use the first part of the piecewise defined function because when you're left of 1, you're less than 1. So therefore, we have to use the piece x plus 2. So that's going to give us 1 plus 2, which is equal to 3. Now let's take a look at our right limit. And for our right limit, we have to look at which part of the function to use. And because right of 1 is greater than 1, we're going to use the second piece. So that's going to be 2 times 1 minus 3, or negative 1. So our left limit is positive 3, and our right limit is negative 1. Because the left and the right limits do not agree, we say that this limit here does not exist. And so because we have the limit not existing at this point x equals 1, we have discontinuity. Because the left and the right don't match, we're going to say that this is a jump discontinuity. And the graph that follows this, you will see that there is a jump discontinuity at 1.